Hello, good evening, everyone. Am I audible?
Yes, but your voice is too low.
Okay, so this is a week 3 solve with us session.
Okay, ma'am.
So is my screen visible?
Yes.
Okay. So in week 3 we have to study about the expectation, variance, covariance, correlation, and some inequalities based on the discrete random variable. So we'll first write all the formulas that we are going to use, and then we will solve the questions. So how do we calculate the expectation for a discrete random variable?
It's the summation over xipi.
Yeah, so suppose x is a discrete random variable. So the expectation of x is, it is the summation. So summation over all the values taken by x. Suppose it is a small x and multiplied by the corresponding probabilities. And the range will be of x only. Right? Okay, so this is the simple formula for expectation. And some properties of expectation. So if you have to find the expectation of Cx, where C is some constant, then what is the formula for
C
it?
times C times
C times
expectation of
T
X.
of
C
x.
times expectation of x. Okay, where C is a constant. And similarly, if we are adding a constant to the variable, then also it will be similar to that
C
expectation of
plus
x plus C,
C.
right? Suppose we have two random variable x and y, and we have to find the expectation of x plus y. Then
Expectation of x plus expectation of y.
yes, so it is simply expectation of x plus expectation of y. Okay, where x and y are two discrete random variables, any two random variable. Okay, now next we have variance. So what is the formula for variance?
Expectation of
It's
X
E
square
of
minus
x square minus
X
P of
square
x whole square.
minus the whole square.
Yes, so the variance of x is the expectation of the squared difference between the variable to its mean. Okay, so this is the definition of variance. Now if we simplify this formula, we can write it like this, that expectation of x square minus expectation of x whole square. So when you open the square here and take the expectation to each term and solve, then you will get this term. Okay, and standard deviation is nothing but the square root of variance, right? Now again some properties for variance. So what is the variance for small ax, where a is a constant?
A square Vx.
A square
A
variance of
square bar
x.
x.
A square times variance of x, right? And similarly, if we add a constant, so variance of x plus a or a plus x, then
Variance of
Value of
X.
Variance
x only.
of
Variance of X.
Variance of
it
x
is
only.
equal to the variance of x only, right? And same thing we can find for standard deviation also. So standard deviation of x, we know that it is equal to the square root of variance of x. So if we take standard deviation of ax, then
A standard deviation of x.
yeah,
A standard
a
deviation of x.
standard deviation of x. Similarly, if we add, so standard deviation of a plus x,
Standard deviation of x.
this is equal to standard deviation of x. Right? Is this clear to everyone?
Yes, ma'am.
Okay, and one more thing. So if we have two random variable x and y which are independent, okay, x and y are independent random variable, then the expectation of xy is equal to the expectation of x
Expectation of x into expectation of y.
into expectation of y. Okay, and in that case the variance of x plus y, so that will be equal to the variance of x plus variance of y. Okay, so always remember these two conditions are correct when x and y are independent random variable. In that case only, if they are dependent, then these will not be correct. Okay, so we have seen expectation and variance. Now the next we have seen in this week is covariance. Covariance and correlation. So what is the covariance formula? How do we calculate covariance?
Expectation of xy minus expectation of x into expectation of y.
Yes. So in short, we write it like covariance of x comma y. So this is the actual formula is the expectation of x minus expectation of x
Into y minus expectation of y.
y minus expectation of y. Okay, and this is a bit. So generally in the calculation part, we have a simplified version of this formula which we use. So this is the expectation of xy minus expectation of x into expectation of y. Okay, so most of the time we use the second formula for calculating the covariance. Okay, next we have seen is the correlation. Okay, and some properties for covariance also. So what is the meaning of covariance of x comma x?
Variance of x.
Variance of x.
Yeah, so it is nothing but the variance of x. Okay, and covariance of x comma y, it is same as the covariance of y comma x. Okay, because we are finding out the relation between two variables, so we can write x comma y or y comma x also. Okay, both are same. Then there is one more note point. So if we have two random variable x and y, which are independent, okay, so in that case we can say that the covariance of x comma y is 0. Okay, so if we have two variable x and y, okay, which are given as independent, so in that case we can say that the covariance between these two variable will be 0, which means x and y are uncorrelated.
But vice versa is not always true.
Yeah, the vice versa is not true. Okay, but if it is given that the covariance between x and y is equals to 0, in that case x and y are uncorrelated only, but we cannot say that x and y are independent also. Okay, so the converse is not true here.
Ma'am, could you repeat the last statement once again?
Yeah, so if you have two variable x and y which are independent, okay, you know this information that x and y are independent random variable. So in that case, you can say that the covariance between x and y will be 0. And covariance is 0, which means that x and y are uncorrelated. Okay, but if you are given that the covariance between x and y is 0, then you cannot say that x and y are independent. You can only say that x and y are uncorrelated. Okay, the converse of this statement is not true.
Ma'am, here I'm having a doubt. Since the formula of covariance, if we simplify, it changes into expectation of xy minus expectation of x into expectation of y. So which is equal to 0, where if they are uncorrelated, and you said we cannot say the dependence of the x and y cannot be determined through covariance.
See, the covariance, the thing is, the covariance gives you the linear relationship between two variables. So these two variables will not be linearly.
There can be some quadratic association might be
Yes.
present.
So the linear relation between these two variables will be absent there, but they can be related to each other in some other way. There can be some quadratic or some other form of relation between them. So in that case, they will not be independent.
The
Okay, if
variables,
they are
right,
independent.
ma'am?
Sorry.
You are talking about the variables, right, ma'am? Like the dependence will be there in other form like quadratic, etc.
Yes, yes. Okay, so we cannot say that they are independent.
No, my doubt is like the formula where we previously discussed, where e of xy is equal to e of x into e of y. Only both are independent. Only, right? If you remember previously in 2 pages ago.
Yes, yes.
Here, like we are not confirming that they are independent. Then how can we say that validation won't be true, right? Did you get my point, ma'am?
One minute. See, the thing is, you're asking that expectation of x and y is equal to expectation of x into expectation of y if they are independent, right?
Yes, ma'am.
So the thing is, if they are independent, then the covariance will between x and y will become 0. Okay, which is true. So if they are independent, then the covariance will be 0. The thing is, if the covariance is 0, it doesn't imply that the two variables will be independent.
Yes, ma'am. I get your point, but at the end of the day, if they're dependent and covariance is 0, which you're telling, then the equation of xy is equal to e of x into e of y will be satisfied, right, ma'am? Even if they're dependent also, in that case. Did you get my point, ma'am? Since covariance formula is e of xy minus e of x into e of y, so if it is equal to 0, we'll just transfer e of xy to the other side and we'll get the formula e of xy equal to e of x into e of y, which is valid only if they are independent.
Yeah, so it is for independence, not for uncorrelated. So this formula is true when they are independent. Independence and correlation are different things.
Okay, ma'am. We will discuss later. I'm not convinced. No problem.
Okay, okay, fine.
We'll discuss later.
Okay, so this is the thing for covariance. Now next we have is correlation. So the formula for correlation, it is represented like this. Okay, it is nothing but equal to the covariance of x comma y divided by the standard deviation of x multiplied by standard deviation of y. Okay, so this is the formula for correlation. And correlation always lies between -1 to 1.
Ma'am, can you please tell what correlation basically signifies? Like,
Yeah. So covariance and correlation both gives you the relationship between two variables. But the thing is, the correlation quantifies. It gives you the strength of the relation between two variables.
strength
And
of linear association or
yes, yes, linear relationship. Okay.
okay,
And covariance only gives you that whether they are related or not, but it does not quantify the strength,
okay,
like how much they are associated. That we cannot know from the covariance. Okay, because the covariance has some units which are very difficult to interpret, but the correlation is a unitless measurement.
yes,
So this is the difference.
okay,
Correlation might be better than the covariance in that case. So covariance might give you the direction whether they are positively related or negatively, but it will not quantify the strength of the association. But by
okay,
correlation, you can get that.
okay,
Okay, so the covariance can be from minus infinity to plus infinity. It can take any value. But the correlation will take only the values from -1 to +1. Okay. And the next we have Markov inequality and Chebyshev's inequality. Okay, so the inequality is if you have x as a is a random variable which is taking non-negative values only. So let x be a discrete random variable taking non-negative values. Okay, with finite mean mu. So then the inequality is that x is greater than or equal to some value. So c is some constant value. So this probability is less than or equal to mu divided by c. Okay. So this
ma'am.
is the Markov's.
Mu
Mu
is
is the mean of the variable x.
mean or expectation.
Expectation or mean both are same here
Okay,
because the x is a random variable.
okay,
Okay. Next we have Chebyshev's inequality. So according to Chebyshev's inequality, let x is a discrete random variable with finite mean and the finite variance sigma square.
Hello, ma'am.
Yes.
Can you show 1 minute correlation one more time?
Yeah. So this is the inequality of Chebyshev's correlation, right?
Yes, ma'am.
This is the multiplication.
Okay. Thank you, ma'am.
Yeah. So this is the Chebyshev's inequality. So in Chebyshev's inequality, we have the random variable, which can take positive values and negative values both. Okay, but in Markov's inequality, the variable should take non-negative values only. Okay, and here we have finite mean mu and the finite variance also. But in Markov's inequality, we use only the mean. Okay, so we use this inequality to get the bound when we don't know the exact distribution of a random variable. In that case, we use these two inequalities.
In Chebyshev's inequality, the discrete random variable can be negative and positive both.
Yes, but in Markov, it should only be non-negative.
And ma'am, how you are saying that expectation or mean is the same thing here? I could not understand that.
See, x is a random variable, so when we are having random variables, we talk about the expectation, and because with random variables, some probability is associated with it. So in that case, expectation mean both are same thing.
Could
So
not
if you
understand.
remember the mean formula, when we have frequency associated with the variable with the values,
Yes.
okay, we multiply x into fx, right?
Okay.
And we take the summation. So here also we are doing the same thing, x into the probability. So here you
Okay.
can see that thing, that the frequency is like the probability here.
Got it.
Okay. So now here we have our first question. So suppose that a game is played with a single bias die. The number from 2 to 6 are equally likely to land face up, but the number 1 is thrice as likely to land face up as each of the other numbers. So in the game, a player wins 120 rupees 120 if 3 turns up, and 180 if a 5 turns up, and he loses 140 if a 4 turns up. So while the player neither wins nor loses if any other phase turns up. Okay. So we have to find the expected money to be won. Try to solve this question.
Ma'am, is the answer 20?
Okay. Everyone has done this question. Should I solve now? What about others? What is the answer? Anyone else who has solved it? See, so we have a bias type. Okay, we are playing with a single bias type. So suppose x is a random variable which is representing the outcome of bias type, right? So since we have a die, so the random variable x will be taking values 1, 2, 3, 4, 5, and 6. Now we want the probabilities. Okay, so it is given that from 2 to 6, they all are equally likely to land face up, which means the probability of x taking value 2, 3, 4, 5, 6 should be same. Suppose it is a. It is some constant. I am assuming that it is a a. And for 1, it is thrice as likely to land face up. So this will be, what will be this probability?
3A.
3k, right? So by using the property of a PMF, we can find the value of a. Yes or no?
Yes.
How we will find the value of a?
Probability sum.
Yeah, the summation of all
3k
these.
equal to 1.
Yeah, so 3a and these are 5 times. So 3a plus 5a should be equal to 1. So from here a will be equal to 1 by 8. Right? Now the question is, in the game a player wins 120 if 3 comes, 180 if 5, and if he loses 140 4 turns up. So we can assume another random variable y. Okay, which is representing, suppose, the price won. Okay, so y here is taking values 120, 180, and 140. But if it is if he is losing, like 140 is the losing money, so we can say that the y will be taking values 120, okay, and 180 and minus 140 because he is losing the money 140. Is this clear to everyone?
Yes, ma'am.
Okay, because this money he is receiving and this he is losing, so that's why I'm taking this money as negative. Now we want to find the probabilities associated with these values, and then we can find the expected money won by the player. So 120 he receives when 3 comes, and the probability of 3 occurring on the die is a. So a is what? 1 by 8, right? So the probability that the player will win 120 rupees is 1 by 8. Is it clear to everyone?
Yes, ma'am.
Okay, similarly for 180 also. So for 180, the 5 number should come on the die, and for 5, the probability is a, which is 1 by 8. So similarly for 140, for minus 140, if the 4 comes. So for 4 also, the probability is again same, a, which is 1 by 8. So now we can find the probability, the expectation of y. Expectation of y, it represents the expected money to be won, right? So it will be 120 into 1 by 8 plus 180 into 1 by 8 minus 140 into 1 by 8. So when you solve it, what is the answer? What will be the value of it?
20.
It is 20. Any doubt in this question?
Oh,
I'm in the same problem. If if you go to the problem statement, assuming that in the game a player wins 120, from that line, if you remove the whole problem, and if you say only expected value has to be calculated, then my assumption is that it will be 1 into 3 by 8, 2 into 3 by 8, 3 into, sorry, 1 into 3 by 8, 2 into 1 by 8, 3 into 1 by 8, 4 into 1 by 8, 5 into 1 by 8, 6. Is that correct? No,
No, that will not give you the money to be won because
no, money is not there. I'm just changing the problem statement. I'm saying in the game a player wins 120. That from that point onwards you remove the problem.
okay.
Completely.
So what expectation you are finding then?
Expectation of the dice, throwing of dice.
Yes. In that case, it will be
Space.
yes, x into the corresponding probability.
Okay, right. Thank you.
Okay. Then the next question is the probability of a random variable x is given in this table. We have to find the variance of x.
And y is given, right? P of y equal to y. Is it
Oh,
a
so yeah, this is a mistake. This should be x. Okay, this is x only, not y. Now solve this question.
Two,
ma'am,
ma'am.
is it 2?
Okay, we'll solve and see.
Yes, ma'am. I got two.
Okay, what about others? So we have to use the simple formula for variance. So variance of x is equals to expectation of x square minus expectation of x whole square. So we need to calculate two things here, expectation of x and expectation of x square. So the expectation of x is 2 into 1 by 5 plus 3 into 1 by 5 plus 4 into 1 by 5 plus 5 into 1 by 5 plus 6 into 1 by 5. So it will be 2 plus 3 plus 4 plus 5 plus 6 divided by 5. So this is 20 divided by 5.
4 आएगा.
So expectation of x is 4. Next we have to calculate expectation of x square. So we have to take the squares of the values taken by x. Okay, so it will be 2 square into 1 by 5 plus 3 square into 1 by 5, 4 square into 1 by 5 plus 5 square into 1 by 5 plus 6 square into 1 by 5.
90 by
Okay.
5.
90 by 5. So this will be 18. Okay. Now simply just put the values in the formula. So variance of x is equal to, so expectation of x square is 18
Minus
minus
4 square.
expectation of x is 4. So 4 square. So 18 minus 16, which is equal to 2.
2.
I hope it's clear to everyone. It's a very simple question. Any doubt from anyone?
Ma'am.
Okay. solve this. So here, let x and y be two independent random variables. Expectation of x, expectation of y, variance of x and variance of y are given. And then we have defined a new random variable t, which is 4x plus 2y. So you have to find the value of expectation of t.
Ma'am, 18.
That's 17.
Okay, what else?
No, no, it's 18.
Everyone has
18.
solved? So t is defined as 4x plus 2y. Now we have to take expectation at both the side. So expectation of t is equal to expectation 4x plus 2y. Okay, so this we can write as 4 times expectation of x plus 2 times expectation of y. And these values are given to us. Expectation of x is 4 and expectation of y is 1.
1.
So it will be 16 plus 2, which is equal to 18. So here we are using the properties of expectation. Any doubt, any conclusion in this question?
Ma'am, why they gave the variance for the other two?
Yes, we have the next part. Now solve this one.
Ma'am, could you once show the question?
Yes. So variance of x is 9 and variance of y is 2. And this is the value for t.
Now, can you scroll down,
Yes.
please?
Ma'am, is the answer 152?
So option B is correct. 1368.
Sorry. Yeah. Sorry, ma'am. My bad.
Okay, so we have to find variance of 3t plus 4. So first we
Is it
have to use the
1368?
properties of. Okay, I'm solving it. So first we have to use the properties of variance. Okay. So this will be what? This is equal to what?
Variance
9
of
variance
3t
of
plus variance of 4. Variance of 3t basically.
no 9 variance of 3.
Yeah, so it will
No,
become actually 3 square times variance of t.
T.
Okay. So this constant gets squared. So 3 square variance of t. So 3 square is 9 and then variance of t. Now we can put the value of t. So t is equal to 4x plus 2y. 4x plus 2y. Okay. So now again what it will become?
16
Ma'am,
times
16
variance
into
of x.
9.
So it will become 4 square times variance of x, so which is 16 times variance of x
And 4 times variance of y.
Plus 4 times
4
variance
times
of
variance of y.
y.
Now we have all the values, we just have to put it and we will get the answer. So 9, 16 into variance of x is 9 plus 4 into variance of y is 2. So after solving, it will become 1368, which means option number B is correct. Okay. Is this clear? Any doubt in the calculation part? Yes, no?
No, ma'am.
Okay, then this is the next question. The probability mass function of a random variable x is given, and then we are given a function of random variable x, which is y equals to 2x plus 1 whole square. And we have to find the expected value of y.
Ma'am, is it 144?
Okay, we'll see. What about others?
88.
Solving my.
Yes, what is the answer?
209.
Okay. Anyone else?
209.
Okay, so the value of y is 2x plus 1 whole square. So actually it is 4x square. We will open the square. 4x square plus 1 plus 4x. Now if we take the expectation on y, okay, and on the right hand side as well, so it will be 4 times expectation of x square plus 1. Expectation of 1 will be 1 only, right? Okay, so expectation of any constant value is always that value. Okay, here C is some constant. So expectation of 1 will be 1, then 4 times expectation of x. Okay, so now we need to calculate two things, expectation of x and expectation of x square. So you can find the expectation of x simply here. So this is 3 into 1 by 6 plus 6 into 1 by 2 plus 9 into 1 by 3. Take the LCM. So it will be 33 by 6, right? Next we have to find the expectation of x square. So minus 3 square will become 9 into 1 by 6 plus 6 squares, which is 36, into 1 by 2 plus 9 squares, which is 81, into 1 by 3. Again solve this. So this is 6. This will be 162. Right? Now we have to put all these values in this equation. Equation number 1. Okay, so from equation 1, expectation of y is equals to 4 into 279 by 6 plus 1 plus 4 into 33 by 6. Right? So this will be 186 plus 1 plus 22. So this will become 209. Is it clear to everyone? You all are solving the question or not?
Yes.
Yes, ma'am. Solving, ma'am.
Yes, ma'am. Ma'am, can you please explain it again?
Yes. So what we have done here, it is given that y is equal to 2x plus 1 whole square. Okay. So first we have opened the square. Okay, so this will become 4x square plus 1 plus 4x. Now we will take the expectation of on both the sides. Okay, so when you take expectation on this, it will become 4 times expectation of x square plus expectation of 1. So expectation of 1 will be 1 only because it is a constant value. Then it will be 4 times expectation of x. So now we need to calculate these two values, expectation of x square and expectation of x, right? So that we can easily calculate from the table.
Yeah, ma'am. I'm
Okay.
just following you.
Is it clear to everyone?
Yes, ma'am.
Okay. Okay, the next question is, so the joint PMF of two discrete random variable x and y is given, and we have to find the covariance between x and y. So the formula for covariance, we all know that covariance is expectation of xy minus expectation of x into expectation of y. So we have to calculate the expectation of x and expectation of y separately and then expectation of xy together. So by using the table, you have to calculate it.
Ma'am, when we are calculating the expectation of xy, then we will have to use the joint probability, right?
Yes. In that case,
And
we'll use the joint probability of x comma y.
okay,
Okay, so
Ma'am, is it 0.01?
Okay, we'll see. What about others? Is it coming 0.01 for everyone?
Ma'am, I got 0.01.
Okay. So expectation of x and expectation of y you can easily find from this table. And then the main thing is to find this value, expectation of xy. So the expectation of x. So how we will calculate it? Yes, tell me what is the first step?
Multiplying 0 with 4 by 10.
0 into 4 by 10. Then
Plus 1 into 8 by 20.
Plus 1 into 8 by 10.
Plus 2 into 4 by 20.
yes. So from the table you can see that values taken by x is 0, 1 and 2. Okay, and the corresponding probabilities, okay, will be 4 by 10, 8 by 20 and 4 by 20. So this is how you can find the value of expectation of x. So this will become 0 plus 8 by 20 plus 8 by 20, which is 16 by 20.
Yeah, the total
Similarly, we
is
can
0.8.
okay. Now next, similarly, we can find the expectation of y as well. Okay, so expectation of y will be 0 into 6 by 20, 1 into 7 by 20, and then 2 into 7 by 20. So 0, first term will become 0, then 1 into 7 by 20, then 2 into 7 by 20. So this is 7 plus 14 by 20, which is
21 by
21
20.
by 20. Now the main thing is to calculate the expectation of x comma xy. Okay, so now how do we calculate it? We have to take xy into the corresponding probability of xy. So this is nothing but the summation xy and probability, x taking value small x, y taking value small y. Okay, now don't worry about the formula, look at the table. So what we have to do, we have to take each pair and then the corresponding probability. Okay, and just start writing your values and add them. Okay, so first one is 0 into 0, so this will become 0, 0 into 0 into 1 by 10, right? So this will ultimately become 0, right? And then when you multiply 0 into 1, then also it will become 0, and then this one 0 into 2, then this will also become 0,
Yes, ma'am.
right? So the first line, first row will become 0. Then coming to the next one, so 1 into 0, that will
0.
also become 0. 1 into 0 into 1, 1 by 5, it will become 0. Okay, I'm not writing these values. Then 1 into 1 by 20, right? So this is something we have to write, 1 into 1, 1 into 1 into 1 by 20, right? Then next we have 1, next we have 1 into 2 into 1 by 10, right? Is this clear to everyone?
Yes, ma'am.
Okay, next will be 1 into 2 into 1 by 10, right? It is 1 by 10. Okay, next we have 2 into 0 into 1 by 10. So this will also become 0. Then we have 2 into 1 into 1 by 5, right? So 2 into 1 into 1 by 5, right? And then the last term will be this 2 into 2 into 1 by 20, right? So
1 by
2
5.
into 2 into 1 by 20. Okay, is this step clear to everyone how we have written these values?
Yes, ma'am.
Yes, ma'am.
Anyone else who has any doubt how we calculate this part?
Ma'am, can you repeat it again?
Okay. So see what we have to do according to the formula. We have to put the values of x, y, and multiplied by their joint probability. Okay. So from the table, we have to take each pair of x and y, and we have to multiply it with the corresponding probability. Okay. So we have to take all the values. So in this table, you can see that the values of x and y are 0 also. So these, when you multiply these three things, it will become 0. Okay, so when we multiply this, this, and this, then also it will become 0. And then you have to multiply 0, 2, and 1 by 20. Then also it will become 0. Okay, now we are coming to the next row. The next pair will be 1, 0, and 1 by 5. So this will also become 0. Then the next we have 1 into 1 into 1 by 20. Right? The value of x into, the value of x into value of y into the corresponding probability. Right? This is one pair. Next we have x is equals to 2, y equals to 1, and the probability 1 by 10. Okay, so in this way you have to take all the pairs and their corresponding probability, and you have to add them. Is it clear now?
Yes.
So this will become
Ma'am,
17 by 20.
ma'am, if we did expectation of x into expectation of y, then it would be same as expectation of xy.
No, no, it is not always same.
Oh,
When x
This
and
is,
y are independent.
yeah, this is same only when x and y are independent. Then only we can say that these two will be same, but not always.
okay, ma'am, got it.
Okay, so now we have calculated these values. So from the covariance formula, expectation of xy is 17 by 20 minus expectation of x into expectation of y. So 16 by 20 into 21 by 20. Okay, 16 by 20 into 21 by 20. To solve it, so this will become 4 by 400, so 0.01. Okay, is this clear to everyone how we calculate the covariance for two variables?
Yes, ma'am.
Okay, then you have to calculate the correlation coefficient between x and y, the same question. Okay, so whenever you have to find the correlation, you need to calculate the covariance and the variance or standard deviation. This is a follow-up question for the same. So the correlation, we write it like this: x comma y. So this is equal to the covariance of x comma y divided by standard deviation of x into standard deviation of y. So covariance term we have already calculated. We need to calculate the variance for standard deviation of x and y. So for that we need to calculate the expectation of x square and expectation of y square. And then we can calculate the variance, and taking the under root of variance will give you the standard deviation. So now try to calculate expectation of x square, expectation of y square.
Ma'am, can you show the table again?
Yes. You have to calculate the correlation, okay? This is your question.
Ma'am, is it 0.0167?
So we need to find the expectation of x square and expectation of y square. So 0 into 4 by 10, then 1 into 8 by 20, and then 4 into 4 by 20. And for y, it will be 0 into 6 by 20, 1 into 7 by 20, and 2 square into 7 by 20. What is the value of expectation of x square?
1.2, ma'am.
Okay. So it will be 8 by 20 plus 16 by 20. So this will be 24 by 20. 7 by 20 and plus 28 by 20. So now we have to find the variance of x and variance of y. So variance of x will be 24 by 20 minus expectation was 16 by 20, right? 16 by 20 whole square. Divided by 400. 224 divided by 400. And then similarly variance of y will be 35 divided by 20 minus 21 divided by 20 whole square. Okay, now just put the values. So the correlation. So our covariance was 4 divided by 400. So 4 divided by 400 and then divided by. So these are variance. So we will take the square root of it. So square root of 224 divided by 400. into 259 divided by 400. So these 400 in the denominator will be cancelled out, and when you solve it, so this is coming out to be 0.016 something. Okay. So your correlation value is 0.016. Is it clear to everyone? Anyone has any doubt?
No, ma'am.
Okay, solve this question. A call center analyst monitors the number of calls received at the center TD. Let X denote the number of calls received in a day. So using Markov's inequality, the analyst determines an upper bound of 0.48 on the probability of receiving more than 249 calls. So calculate the mean of X.
Ma'am, I got 119.52.
Okay, what about others?
Thank you.
Okay, so the question is that a call center analyst monitors a number of calls received at the center daily. Okay, so X is denoting the number of calls received in a day. So using Markov's inequality, the analyst determines an upper bound of 0.48 on the probability of receiving more than 249 calls. So the probability that X is greater than 249. Okay. So for this, the upper bound is given. So this is 0.48. Okay, but according to the Markov's inequality, we know what is the Markov inequality. It is X is greater than or equal to some value less than or equal to mu by C. Right? This is the Markov inequality. So you can see that there is a greater than or equal to sign. And the variable is also discrete variable. Right? So probability X is greater than C and greater than or equal to C might be different. So how we can write it? So it is writing that more than 249. So we can write that x is greater than or equal to 250.
250.
Right? Because it is a discrete variable, so we can write it like this. Now by using the Markov's inequality, this should be less than or equal to mu by c. So c is what? C is 250 here, right? So we
Yes.
can write it as mu by 250. Okay. Now this probability is given to us as 0.48. Right? The upper bound is given as 0.48, which means that mu by 250, this should be equal to 0.48. Right? Now from here we can calculate the value of mu, which is mu. So it will be 250 into 0.48. So when you multiply, it will be 120. Okay.
Ma'am, a small clarification over here. 0.48 is the can we say it is the chance of receiving more than 250 calls is 48% than the mean? Can we say that?
The chance of getting more than 250 calls
than the 48% than the mean. Like there is a chance of 48% receiving 250 calls, more than 250 calls. Can we say that?
Okay, 1 minute. What you are saying that the chance of getting more than 250 calls, right? This is equal to 0.
40.
Yeah, okay, yeah, 0.48 times 0.48 of mean.
Yes, ma'am.
So this is 1 by 250 is not 0.48. So this is wrong. This is 1 by c times mu, you can see. 0.8, 0.48 is actually the upper bound. So the probability that you will get more than 249 calls or equal to or greater than 250 calls. So this probability will be less than or equal to the 0.48. This is given to us. Or you can see that, say that 1 by 250 times me. Okay, or you can directly say that the probability of receiving more than 249 calls will be less than or equal to 48%.
Okay. Yeah, it's the opposite way, which I said, right?
Yeah. Yes.
Okay. Yeah. I get it.
Ma'am, this basically in a basic question. How this 249 is translated into 250? Ma'am, could you please explain this?
Yes. So the question is saying that probability of receiving more than 249, and it is a discrete random variable question, right? So more than 249, which means if you translate it into the inequality, it is probability x is greater than 249, right? This is something which is given. Now we have to use the Markov's inequality, and according to the Markov's inequality, this is our inequality. So in this inequality, there is a greater than or equal to sign. Okay. And here in this inequality, we have only greater than sign. So these two will not be same actually, because it is a discrete variable. If it is a continuous variable, then we can say that these two are same, greater than equal to or greater than. But it is a discrete, so these two probability are different. So now we can convert it, and we can write it like this, that x is greater than or equal to 250, because more than 249 call, which means that equal to 250 or more than 250, right? So now we have converted it according to the Markov's inequality, and now we can directly use it. Okay.
Yeah. Yes, ma'am. Clear.
Anyone else has any doubt?
Yes, ma'am. In case I'm just trying to know, modify this question, like probability of receiving between, say for example, 249 and 260, something like that. It comes in within the range between.
So
Same
in that
question.
case, yeah, we prefer Chebyshev's inequality because we have the formula for it when two values are given. Like the x is taking values between this and this. We use Chebyshev's because here we have like x is, we can find x is greater than equal to c, or we can find x is less than c by doing 1 minus. Okay, if you're trying to find between two values, you can use Chebyshev's inequality.
All right, thank you.
Okay, is this clear to everyone now? Should I move on to the next question?
Yes, ma'am.
Okay. Okay, so next question is based on your Chebyshev's inequality. So the number of people X who make reservation in a seat on a particular day is a random variable with mean equal to 5 and variance equals to 4. Now find a bound on the probability that on a particular day the number of reservations made will lie in between 1 and 9 using the Chebyshev's inequality. Now try to solve it.
The option.
Option B or C?
Option C.
C.
Option C.
Option C.
Okay, so the question we are given a random variable x and the mean is equal to 5 and the variance equals to 4. So the expectation we can write, it is 5 and the variance of x is given as 4. And the question which is asked is the probability that on a particular day the number of reservations made will lie between 1 and 9. So x is lying between 1 and 9. This probability we have to find by using the Chebyshev's inequality. Okay, so if you remember the Chebyshev's inequality, it is something like that. So it is actually like one more form of the same Chebyshev's inequality, which we can use here. Okay, so earlier we have seen the Chebyshev's inequality as this, that mod x minus mu is greater than or equal to k sigma, so which is less than or equal to 1 by k square, right? So this is the same thing. Okay, these two are same. So when you open this mod and you solve, you will get the same value. Okay, so here the question is given in this form that x is lying between two values, so we can directly use this form of Chebyshev's inequality. Okay, now we are given, you can compare these two, so this one and this one, and you will see that mu minus k sigma, it is equal to 1, right? Also mu plus k sigma will be equal to 9, right? And we know the value of mean and variance here, so we can easily calculate the value of k. So mu is 5 minus k into sigma, which is standard deviation, so it will be square root of 4, right? So 5 minus 2k, it is given as 1. Okay, so 2k will be equal to 4, so k will be equal to 2, right? Is it clear up to this point?
Ma'am, this mu minus k sigma equals based on what we have written, ma'am, or made a mistake actually?
See,
The first step actually.
yes, so see, this is the Chebyshev's inequality, okay, and this is the probability
Yes, ma'am.
which we have to calculate. Now if you look at both these inequalities carefully, so here also x is lying between these two, right? So x is greater than or less than these two values, and here also x is greater than or equal to these two values. So if this is something like that, the value is, this probability is greater than or equal to 1 minus k square. So we can actually compare these two.
Yeah, clear, ma'am. Got it. It's just
Okay.
equating
So,
both the equations. Yes.
Yeah, okay. And you can also use mu plus k sigma equals to 9. From here also you can calculate the value of k, it will be same. Okay. So now we can simply calculate this value 1 minus 1 upon k square, right? So from here 1 minus 1 upon k square. So this will be for our question which is asked. So 1 minus 1 upon, so k is 2, so k square will be 4. Okay, so this will be 1 minus 1 by 4, which is 3 by 4. So now in our question, the probability that x will lie between 1 and 9, okay, this is greater than or equal to 3 by 4, right? Just look at the inequality carefully. So this probability is greater than or equal to 1 minus 1 upon k square. So this value we need to calculate, right? Which we have calculated. So the probability that x is greater than 1 and less than 9, okay, x is lying between 1 and 9, is greater than or equal to 3 by 4. So now just tell me, is it the lower bound or the upper bound?
Lower bound.
It's the lower bound, right?
Lower bound, right? Okay, so whenever greater than or equal to, which means it is the lower bound, because this probability is greater than or equal to this value. So obviously it will be lower bound. And when there is a less than or equal, which means it is the maximum value given to us. So this will be our upper bound, right? So always be clear with these things. So what will be it? It will be according to the options. It will be at most or at least. Is it the probability is at most 3 by 4 or at least 3 by 4?
At most.
At least.
At least.
It should be at least,
At
right?
least.
At least 3 by 4, because this is the lower bound. So at least means this is the minimum value given to us. Okay, so it could be at least 3 by 4 or greater than this. At most means the maximum value is 3 by 4. So it should be less than or equal to 3 by 4, which is not the case here. Okay, so this is the at least 3 by 4 and not at most. So option number C is correct here. Okay, everyone is clear with this question? Any doubt?
Ma'am, can you explain this formula, derivative of the main formula to the square one, where you put a rectangle around that, right? How you arrived at x minus mu greater than equal to k sigma less than equal to 1 by k square, how it
Yes.
transformed into the formula. Can you just explain this?
So the main formula, the main Chebyshev's inequality which we have studied is the mod of x minus mu is greater than or equal to k sigma, and this probability is less than or equal to 1 upon k square.
Okay, ma'am. Yeah, that's the
Okay.
main formula.
Yeah. Now we have x mod of x minus mu greater than or equal to k sigma. I am solving it separately. Okay.
Sure.
So this mod, which means it could be positive or negative, right? So if we
Correct.
take the positive case, it should be x minus mu greater than or equal to k sigma.
K sigma.
Okay. So it will be x is greater than mu plus k sigma. Okay. And then if we take negative case, so it will be minus x plus mu greater than or equal to
K sigma.
So it will become okay. We are just transferring this minus sign.
Clear.
Okay?
Yeah, it's clear.
Okay.
Sure.
So it is like x is between mu minus k sigma and mu plus k sigma. Okay. So what we have to do, we will do the 1 minus thing.
Ma'am, this minus x greater than equal to k sigma minus sigma. So it's the signs are only changing, right? You are not. Why you are changing the less than greater than equal to less than equal to, because you're also changing the signs. So minus x has become x.
Yeah, so I have changed it here.
Okay.
Okay. So now we will do 1 minus of this. Okay, so in this you can see it is less than or equal to sign. When you do 1 minus of it, it will become greater than or equal to 1 minus of 1 upon k square. Okay, and it will be mu minus k sigma to mu plus k sigma. Are you getting my point?
Sure.
Okay, anything else? So you try to solve all the questions based on week 3, your activity, your practice assignment, and we can discuss the questions in the next doubt session. So on Tuesday we will have our week 3 doubt session. Also on Wednesday there is a slight change in the schedule. So on Wednesday we will have our week 4 solve with the session. Okay. Just remember this thing. We will send the mail also, but still I am informing you all that on Wednesday it will be week 4 solve with the session. Also one more thing, that in the quiz 1 the syllabus is from week 1 to week 5. Earlier it used to be week 1 to week 4, but this time it is going to be week 1 to week 5.
Why, ma'am?
It might change according to the calendar every term. So it is not like each term it will be fixed. It might change, and whatever it is going to be, that will be informed to you. So
What will be the syllabus for quiz 2?
Quiz 2 will be week 5 to week 8.
Okay.
Excuse
Week
me, ma'am.
5 will be repeated again?
Yes.
Okay.
Ma'am, I'm having a doubt. Ma'am, regarding covariance in the starting, we were discussing. Are you free right now? Can we discuss about it?
Sorry, one thing I missed. Quiz 2 is week 1 to 8, not week 5 to 8. Sorry.
Ma'am, I want to know when we will be able to access the recording and the PPTs of the previous lectures, because we can't access the lectures of stats.
Recording of previous. What do you mean by previous?
The last session's recordings we are not able to access.
You can find it on YouTube, or the links is also available on the calendar.
Yeah, ma'am, that's what I was saying. The calendar link is not available. It's saying
Ma'am, I think he's asking about the TA session recordings.
Okay, TA session recordings. Okay, we'll see. We have to do some changes maybe, so we'll see.
Ma'am, it's not accessible. It's just
Okay,
asking
okay.
for permission.
Okay, we'll see. I'll change the settings and all.
Ma'am, Wednesday on 25th, week 4 solve with a session. On 25th.
Yes, this 25th only we will have week 4 solve with us. We will send the mail also, but still I informed you.
Ma'am, I'm having a...
Today's session PDF will be uploaded into the portal.
Yes.
Okay, thank you.
Ma'am, regarding covariance, will you able to discuss right now, ma'am?
Yes. Yeah, what's your question?
Ma'am, there is a property in covariance where you said if covariance is like uncorrelated, they need not be independent. Is the case you discussed, right?
Yes, covariance is 0. Then they need not to be independent. Yes.
Yes, ma'am. So
they
the
might be or they might not be.
Yes, ma'am. Okay. The formula of covariance is expectation of xy minus expectation of x into expectation of y. So in this case, the covariance would be equal to 0. So we will equate the equation to 0, where then expectation of xy is equal to expectation of x into expectation of y will be the answer, right, ma'am? Are you able to follow till this point?
Okay.
Ma'am, the same equation where you have discussed previously in the previous pages, where you said this equation is only possible if the both variables are independent, but here they are dependent. Then how could this equation be written like that? Is my doubt.
Okay, 1 minute. So, like you are saying that if covariance is 0, then expectation of xy will be equal to expectation of x into y always.
Yes, ma'am. That's yes, ma'am.
The thing is, these two, like this is one of the case that if the covariance is 0, then expectation of xy and expectation of x into expectation of y are same. This is one of the case, but it is not always like the covariance is 0, then they both are same. Maybe the expectation of xy is also 0, and multiplication of xy, multiplication of expectation of x and expectation of y both are 0. In that case also it will be 0 minus 0 and 0. So the thing is like the condition is if the condition expectation of xy is equals to expectation of xy. I hope I'm not.
Yeah, I could sense that.
Okay. So this is one of the cases. The thing is the covariance is 0, then they might be independent and they might not be independent. Both the cases are there.
Yes, I agree with that point.
So how it is going to be 0 can contain different cases.
Okay, ma'am.
Okay, I will see this thing again and we'll try to better explain it.
Ma'am, another doubt I'm having. If two random variables are independent, you said variance of x plus y could be written as variance of x plus variance of y.
Yes.
Ma'am, there is a question in activity questions. Assignment, there is a question where variance of x minus y is also equal to variance of x plus variance of y. If we do in such manner only, we are getting the answer.
Uh, so, okay, 1 minute. The thing is, 1 minute. I don't have space. Like, okay, I'm writing it here. So the variance of x minus y, it is being equal to variance of x plus variance of y, right? So this is happening because yes, they both should be independent. This is also one of the case. Okay. Also, what we do when we take the variance, the coefficient gets squared, right? So suppose
Yes, ma'am.
the thing is, if you write variance of ax minus by, okay, so how it is going to be? It is a square times variance of x, okay, plus, so the coefficient of y is minus b, right? So minus b square variance of y, okay, so it will be a square variance of x plus b square variance of y. Now in this, when variance of x minus y, you can see that the coefficient of y is being minus 1 here.
Yes, ma'am. I
Okay.
understood, ma'am.
Okay, also this is also like both should be independent. Okay,
Yes, ma'am.
because if they both are not independent, covariance terms also comes when you calculate variance between x plus y. So it is like variance of x plus variance of y, and then if they are not correlated, then covariance terms also comes in the formula. But I think this is not in your syllabus. I'll check it again. But yeah, so we have to study the independence part. Okay, so
Okay,
if
ma'am.
they are
Yes, ma'am.
independent, then this covariance terms becomes zero. So in
Two
that case,
times
the
two times
variance,
covariance of x and y.
yes, yes, I'm just saying that the covariance terms comes here. Okay, I'm not talking about the exact formula.
Then I can give example about covariance. If it is covariance is 0 and x and y is dependent.
Okay.
And in this case, it is possible y is equals to x square. Y is dependent on x.
Yeah,
You
so
can
if you have seen the lectures, you will find the examples of these type of things where they are uncorrelated but not independent. These things.
Since minus variance of x minus y, then equal to vx plus vy.
Sorry, what?
And this is in negative now. X minus y and variance of x plus y both are getting some. I thought it will be vx minus vy.
That's what I have explained here. We have to square the coefficient. So after you square, the minus sign will become positive.
Okay.
Okay.
thank you, ma'am.
Thank you, ma'am.
Okay, then thank you everyone for joining. We will have our next session on Tuesday.
Thank you, ma'am.